Hello guys and welcome back to another episode of this series. This would be part 2, I believe, of us writing our virtual memory manager. So let's see where we left it off. So if I remember correctly, I've moved all the memory stuff here, and we've started by setting up some a base, I guess, a structure for our virtual memory manager. And we did have quite a few things to fill in, so all the implementations. So that's what we'll try to do today. Okay, so I think we are going to start by doing this here. We are going to need to read control register 3 and get the current page map address from there. Right, so here, so for CPU ID, when we use that, we create a module to bundle that in there. So I think I'm going to do pretty much the same thing here. So I'll create a module called registers .zig, and in here I'll have a public function which I'll call read control register, something like this, in which I'll have a comp time register, which would be given by some sort of enum, I guess. Yeah. And this here would return a US64. So I guess all control registers should be 64 bits in width. So we can just keep this. And since we are just reading, we can use assembly directly. And we are going to need to do something, but first let me just sketch out what I want to do here. So let me try to remember. We are using AT&T syntax, so this should be something like this, CR3, which is our source, and we put it somewhere. Let's call this page map. Right, and these are our outputs. So I guess page map will need to choose some sort of register to clobber, and for this I'll choose R8. And I'll also tell it that this should be our output, our return. And it means that here I can just write return. We have no inputs, I think. And we are clobbering R8. So that should be it. And of course, I'm going to have to declare register as an enum. I don't need it to be backed by anything, so here I'll just go ahead and write CR3 in there. Let me do this, since this is the new Zig way. And here now we can actually do comp time. What should I call this? I'll call this read instruction, and this would be so first of all, let's do comp time register name, and this would be let's switch on registers, and for CR3 we are going to return C. Actually, let me just bundle all of this in there. No, actually, never mind. Should I actually just use tag name for this? I feel like tag name would be good match for this. So tag name of register, and here the instruction would be so move, then that. Then since this is comp time, we can just do this, and I believe we are going to also need to do something like this and page map. Not nap, but map. Right, so here it's, oh yeah, of course. Yeah, sure. And of course that's unused because I still haven't used it, so read insert. Okay, that should do the trick, I believe. Just going to need to check on the syntax for the clubbers. I believe we already have that in something called IO that we've created here. Okay, so it's just a comma-separated list of registers that we are modifying, so that should be okay. Cool. Okay, so that means that now we can actually go ahead and add a few other registers to this. So let me add CR2, maybe CR4 for now. Okay, that's looking good. So here we can actually go ahead and do registers.read CR3, and of course we are going to need to declare where that comes from. Registers is import registers.zig. There we go. Okay, so where were we? We were here. That's the U64, that's correct. And we actually have started working with this here. But we still don't have these quick maps and quick map page table entries mapped to virtual memory. So actually we are going to go ahead and do that, and I think that's in our bootloader map kernel space. Yes, this is what I was looking for. So here we have our kernel being mapped, and this is the boot info. So let's just come over here just before the boot info, and actually we are going to need we are actually going to need to know where our kernel will end. So how do we go about that? Because in the kernel itself, we have in our linker script a symbol that tells us where the kernel ends, basically. But in our bootloader, I think we are just going to have to compute, or rather just keep track of the last page we've written our kernel to, or we've mapped for our kernel. So I believe that should be what we are going to do. So what is the last page we write to? We get all the pages here, and we keep incrementing the pages here. So we'd like to have either of these, either the, or not either, but I think the mapping v address is what we are interested in. Right, so let's create var kernel n, and this would be actually this should be a U64. Yeah, for now let's give it a U64, and here we are going to set kernel n to whatever the last, so mapping the address. What is this? This is a U64, I believe, yes. So that should give us our kernel n Right, so now that we have our kernel n, we are going to try to map that. Actually, let me go back to vmem here. I'm just going to copy this, and these two. Yes, because we are going to need them. So quick start map would be kernel n plus 2 pages, as we've said previously. Actually, let me just go ahead and do rename this to arc page size. And let me just rename this to max CPU. Okay, so that means that now we have the correct values. And here we align for the so I guess we don't have page mapping, but do we have a map dot page mapping? No. Kernel space? Address space, maybe. Yes, okay. Right, so that's that, and now it's going to complain that it's not used, of course. Right, so first of all, let's map this. So we want our quick map address, which is the pages between these two, or rather the pages starting at this address here and having this length mapped to, well, basically our address space. So we are going to do this and just copy this over here. And actually we can pages by just removing this thing here. So, and of course we can do something like map pages. Here we don't really need these. We are just going to need a variable. Quick map page is quick map start, and we are going to actually put back that defer. So we are going to add constants arc page size to that. Right. There we go. So here we are going to, so v address, we already know of that. So that's quick map page. Right, so that's the virtual address we want to map to. Now, what is the actual physical address of our quick map? That's another question, actually, we need to answer. Actually, we can just give it some value, some traceable value. So for now, I'm just going to do something like this. Sure. So I'm just going to map all of them to that beef. And here we have quick map page. So the idea is just to have the physical, the virtual mapping present. And we don't need this anymore. Right, so this means that we have mapped all our pages. So now we are going to need to actually go ahead and map the page table entry for all our pages. So we have the virtual address for our page table entry. So now we are just going to actually do pretty much the same thing here. And we are going to need a variable quick map pt entry page, which would be quick map pt entry start at first, and this one here. So quick map pt entry page, right? Quick map pte page, and this one here we actually do have a virtual address for. So let's compute that virtual address for this. So we would like to get the address of our page map, and then get, actually, let's first start by just doing, let's convert this address here, this virtual address, so const quick map page. Right, so quick map page would be, actually we also need to track the quick map page itself. Right, so this one would need to be quick map start. Yeah, and this would also need to be quick map page. Yep, that's correct. Right, so quick map page, let's call this address, and this would be a address space dot address, and this would be a so hold on, let me think about this. So a virtual address, and this would be a bitcast of whatever that quick map page is. Actually, might even try to avoid this. So this would be PML4 page mapping, PML4. I know I've put it somewhere, just need to remember where it was. So this one here. So this one is not public. So maybe I just need to make it public. That means that now I can use this here, so PML4 virtual address, and now I can just avoid doing all of this. Yeah. Okay, so now that we've bitcast that address to whatever that is, so we can get its page table entry. So the const pte from that address is quick map page address dot page table index. Yes. So now that we have the page table index, we need to get the actual page table physical address and map that instead of this here. So const pte address would be, so how do we go about this? I believe we can actually just take a look at our address space here. We should have all that we need to get the page entry. So basically this code here, rather this code here, from here to here, this entry we get is the basically the address of our page table entry. So maybe we'd like to package this into a function and make it public. So get page table entry, of course wrong language for this, page table entry, and this would take a self, which would be a const pointer to self, maybe some v address. Not sure we need the p address here, except that this time this v address here would actually be a PML4 virtual address, and I believe that's all we need. This would return bootloader error or some sort of entry, so page mapping dot entry, or rather a pointer to that. Right. So maybe I should I'm thinking. We also might need flags. So flags, and that's mmap flags. And that should be it, I think. I'm just going to rename this to the address, sure. Okay, so the address. Okay. And of course, we are going to return entry. That should be okay. And that means that here we can get rid of all of this and just replace this by self.get page table entry and pass it virtual address and flags. And of course, we are going to need to try this. Right. So now that we have our page table entries address, we can actually just go back to our main here and do, so we are going to need a page map. Do I have that? Address space dot get, perfect. Page table entry, we need a virtual address, so we actually already have that, page address. And we need flags. We need flags. Can't we actually just have flags be the default flags? So I guess we can just pass in the default flags. And I think the default flags should be under so address space and default mmap flags. Yes. And of course here we are going to need to try that. Not sure if this function here is available. And it is, so that should be okay. Yes, that should be okay. Right, so now that we have that, we get the address, and actually we can, I believe that this entry here is a U64, basically, just a U64, and we have its address. So from this address here, we can get the physical address if we so choose to by calling this. Actually, no, we don't need the physical address. We need this actual address of the entry itself. Right, but we need the address to the entry page align because we have selected one PTE within a table of PTEs. So we are going to need to page align this. So so it's stud mem and align backward, and this would need to be aligned to 64, and that's my address. Actually, let me just do this. PTE address page address, and this would be so mem align backward with comp time t would be U64. The type would be rather the address is PTE address, and the alignment is constant arc page size. Does this fail? It does not. Right, so now we have the actual address, so we are going to need to pass that page address here, and also here, PTE page address. Okay, and I think that solves that. Oh, we already have this called quick map page somewhere else. Okay, so I guess we don't need to redeclare that. We can just use that. And here we did not need to actually compute the index because we have our helper here to do that. And that's all good, I think. So we just need to actually add a few logs to make sure that we have, in fact, mapped the correct address to the correct PTE. So here I am going to expect that our address here, which we can actually compute kernel and +2 pages, would be something that we should know. We can compute from the size of our binary. So for now, I'm just going to do info and kernel and found at something like x. Sure, and this would be just kernel and here let me put this to info, and once we've mapped our kernel space or our address space to with a map, we should go here and do this as info. And here we should see that this is the actual physical page of whatever was created here, rather here, in this map here. But how do we see that? Actually, we can see it by printing this entry here. So log info quick map PTE. And this would be so let's do this and then let's do this. Yeah, and this would be so what was it called? So PTE address, PTE address, and I guess a second time PTE address. Right. Okay, so now we are just going to need to build this and see where we've messed up again. So what is the issue here? The issue is this. So quick map address is something that we need to compute from our CPU IDs, but for now we are just going to choose the first one. So that this would be, well, basically entry, so add bitcast of entry. Actually, it could be int from pointer. Sure, this could be int from pointer of entry. And what is the other one here? We need to invalidate TLB for quick map in address, which we don't have, which we are going to create somewhere here. There we go. So that should make it easier for us. So let's build this and see what we get. So I guess we did mess up a few things in our bootloader. So let's do something here. So arc page size. And if we go just to our Zig stuff. Oh, so maybe I should just save all and rebuild. Cannot cast bitcast from comptime int. Okay. So where was that? That was somewhere here. Right. So where was that? Okay. So let me just do something like this. So const temp or placeholder address is AU64, and that should have a value of dead beef. and this would be a placeholder address, and this would also be a placeholder address. All right. So what's the matter now again? Page mapping is not marked as public. Page mapping is not marked as public. Where did we use page mapping? Oh, so somewhere over here. Well, let's make it public then. And I guess we'd have the same with this. Let's see here. Overflow of integer utype value. Did I mess up something? So where was that? In main, I think. So as U64, arc page size times the max CPUs. Should I probably do something like this? So expected U64 found a pointer to address space of whatever, and that's somewhere here. Of course, so in from pointer of PTE address. Right, so invalid format string X, we can deal with that fairly easily. So that should be here, and this should be in from pointer of PT address. Okay. Well, it did build. Now let's see if it's not going to explode. Sure. Okay, so we are going to need to go back up here. We are overwriting a present entry for some reason. Okay, first of all, let's take a look at where we are mapping our quick maps. So the beef goes to that, because we found our kernel and here. And does that look good? I believe it does not look good. It does not look too good, I think, because this goes from here to this address here, and it has this size. So I'd expected this to have a 5 here. Right, but here we have 3, so we are one page. This is weird though. Why do we already have something written to this? So, I think we've made a mistake somewhere. Because it says that we are overriding the last value with the newer one. So, hold on one second. So we are mapping this to this. Oh, these are inverted, aren't they? This should be placeholder thing. Yeah, okay. And that should be also the case here. So this is page address, this is the physical, so PT page address, and this one is quick map. page. I believe, no, actually, hold on, that's not it. P address is PTE page address, and this one here is the quick map page. Yes, okay. Right, let's stop this, rebuild, and see where we go. Okay, so let's see here. So now we have mapped, okay, so we don't have the warning anymore. We have our quick map PTE at this address here. Let's see what the actual physical address it's mapped to is. Do we have that? Okay, so the format is not great. So since we are here, let's do something about that. So let's think for a bit. Actually, I don't want to be yeah, I don't want to display the full PTE address. So P address is that, and this should have something like this, something like that, and this would be, I believe we do have a get address on there. Yes, okay. So let's try this again. All right, let's see. Okay, so we do have this pointing to this address here. But hold on. It says that we are overwriting the addresses now. It's not great. That is not great. That is not great, because this is not correct. This is the, rather, okay, so we are doing something that's not good. I believe that this here should not be the page. Should not be the quick map page. This should be, oh, wow. Yeah, this should be our quick map PT entry page. Wow, that's a big one. Entry page. Okay. Right, let's see where we go from here. Okay, so now we are mapping this address here to this address here. Okay, and this address here, so BD74000 is where is it? Oh, so it's this one here that we have our PTE in. Okay, so this one is correct. There's one last problem we have here. That is, we have the length of our PTE map entries, but we don't have the number of pages that needs to fit them. Because if we go back here, as we can see, so all of these, so 48A8, 48B0, 48B8, all of these fit in the same page, basically. So we just needed one page to map all of them, whereas here we've actually used 8 pages, which is a bit wasteful. So let's go back to here. So here we are lining forward the this thing here. but we need to take this divided by the size of a page. So const quick map pt entry pages, and this would be quick map, or rather should do div exact or div so that's the math div seal. Yeah, okay. This would take quick map pt entry length and constants arc page size. And this can, does this take, it takes a type u64, and it can fail, so let's give it a try. And of course this is not used, so we are going to need to go to pt quick map pt entry pages. All right, let's rebuild and see. Oh, expected type error. Oh, right. Okay, so the error type is not correct. Actually, we are pretty sure this is not going to fail. So here's what I'm going to do. I'm going to take all of this out. I'm going to do add div floor and if quick map pt entry pages is 0, oops, then quick map pt entry pages, or yeah, pages is equal to 1. That's the only case we need to actually, no, never mind. Actually, okay, let's do this the actual smart way. There we go. Let's do that. And that should give us just one page, I believe, to map. And that is correct. So we just have one single page mapped that has that address in there. Well, actually, that page would have all of our PT pages in there, because they all fit in the same page, which is pretty cool.